Today we will discuss about redox reaction. Redox means summation of oxidation and reductions. Red is for reductions, OX is for oxidation. Now in this part we have to balance chemical equation by two methods. Number one, ion electron method. Number two, oxidation number method. In ion electron method, you will have equation in ionic form. In this reaction, you can see that MnO4 is giving you Mn2 plus and Fe2 plus is giving you Fe3 plus. So MnO4 minus to Mn2 plus is your reduction step, as it is losing 4 oxygen atoms. Fe2 plus to Fe3 plus is your oxidation step, as iron is giving 1 electron, because we know electron loss is oxidation, oxygen loss is reductions. So first of all, we have to divide this equation into two parts. One is oxidation step, other is reduction step. So in oxidation step, we will take Fe2 plus to Fe3 plus. Now after getting oxidation step, you have to balance element first, then you have to balance charge by adding electrons. Fe2 plus to Fe3 plus, in your left 1 iron, in your right 1 iron. So element is balanced already. Next you have to balance charge by adding electrons. So in your left you have 2 positive charges, in your right you have 3 positive charges. So 1 electron if you add to your right, then number of charge will become 3 positive, 1 negative, makes 2 positive. In your left 2 positive. Now charge are balanced. Next, in reduction step, you will have MnO4 minus to Mn2 plus. In this step, MnO4 minus is giving Mn2 plus. So number of manganese is 1, number of manganese is 1. Now we have to balance oxygen by adding water to the opposite side of the oxygen. So 4 oxygen can be balanced using 4 water molecules. To balance oxygen, we have taken 4 to the 8 hydrogen atom. So hydrogen will be balanced by using H plus. So I am taking 8 H plus to balance hydrogen. Next you have to balance charge by adding electrons. Next 8 positive charges, here 1 negative charge. So ultimate 7 positive charges in your left. Water is neutral, so 2 positive charges in your right. So in your left 7 positive charges, in your right 2 positive charges. So 5 positive charges are extra in your left. So you have to add 5 electrons to make it neutral. Now count 5 negatives, 8 positives, 1 negative, ultimate 2 positives. In your right 2 positives. Now charge is balanced. Next, we know when a redox reaction takes place, number of electron loss should be equals to number of electron gain. So here in the first step, that means in oxidation step, 1 electron is in your right, and in reduction step 5 electrons is in your left. So we have to make electron equal in both the equations. So you have to multiply equation number 1 by 5 and equation number 1 by 1. Then you are getting 5 Fe2 plus to 5 Fe3 plus plus 5 electrons, and by multiplying equation number 2 by 1, you are getting MnO4 minus plus 8H plus 5E gives Mn2 plus 4H2O. Now, if we add these two steps, then we will get our ultimate balanced equation. MnO4 minus plus 5Fe2 plus 8H plus. These two electrons get cancelled, equal to Mn2 plus 5Fe3 plus 4H2O. This is your balanced chemical equation. This is the procedure to balance an ionic equations by ion electron method. Next, we will learn about balancing chemical equation by oxidation number method. Suppose you have this equation: potassium permanganate is reacting with hydrogen sulfide in presence of sulfuric acid, gives potassium sulfate plus manganese sulfate plus sulfur plus water. In this equation, manganese and sulfur are the variable elements. So, from KMnO4 you are getting MnSO4. In MnSO4, manganese is the variable elements, and in H2S, sulfur was the variable elements. From H2S you are getting the sulfur. Now, calculate the oxidation number of manganese in KMnO4. Oxygen has -2 oxidation number, so -2 into 4 -8, potassium is +1, -8 plus 1 gives -7, so manganese is +7. In H2S, hydrogen is +1 into 2 +2, so sulfur is -2. In MnSO4, as a radical, sulfur has -2 oxidation number, so manganese 2. Sulfur in elementary form, it will have oxidation number as 0. Now, change in oxidation number of manganese is equals to 7 minus 2 into 1. This 1 is coming as number of manganese is 1 here. We have to multiply the change in oxidation number with a number of that element in your left, not from your right. Next, change in oxidation number of sulfur from H2S, 0 minus of -2, always greater minus less. That means change in oxidation number should come in positive, into 1, because number of sulfur atom is 1 here. So, you are getting 5 and 2 as change in oxidation number of manganese and change in oxidation number of sulfur. So, here manganese is to sulfur, you are getting 5 is to 2. So, in place of manganese, when we will put the compound containing manganese as KMnO4 and compound containing sulfur as H2S, then this ratio will be reciprocal. That means it will be 2:5. From this ratio, we are getting the ratio of KMnO4 and H2S in our primary equation. So, we will put 2 before KMnO4 and 5 before H2S. Now, we have to balance variable element first. Manganese 2, so put 2 before MnSO4, number of sulfur 5, so put 5 before sulfur. After balancing variable element, you have to balance metal. Metal is potassium, manganese is also metal, but when we are considering it as variable element, so only potassium is metal here. So, number of potassium is 2, number of potassium in this equation in your right is 2, so it is already balanced. Next, after metal, you have to balance acid radical. Acid radicals means the negative part which is coming by the dissociations of acid. For example, SO4 2 minus, Cl minus, PO4 3 minus, these are acid radical. In this equation, SO4 is the acid radical because we are using H2SO4 as an acid. So number of sulfate in your right is 2 and 1 3. So put 3 before H2SO4 to balance acid radical. Next you have to balance hydrogen. Number of hydrogen, 3 2s are 6, 5 2s are 10, total 16. So put 8 before water to make balance hydrogen. So ultimate equation is coming as 2 KMnO4 plus 5 H2S plus 3 H2SO4 gives K2SO4 plus 2 MnSO4 plus 5S plus 8 H2O. This is your balanced chemical equation.